Hello, let us find sine of theta given cosecant of theta. Sine and cosecant are two reciprocal functions, so we can always find one of them knowing the other. So sine is reciprocal of cosecant of theta. It equals to 1 over cosecant of theta. So we can substitute square root of 14 over 3 for cosecant of theta. There are two ways how we can solve this. So we divide 1 by square root of 14 over 3. When you divide by a fraction, you multiply by its reciprocal. It is the same as multiply 1 by 3 over square root of 14. Or you can think about it as 1 divided by square root of 14 over 3. You have here fraction in denominator. You can clear this fraction by multiplying both numerator and denominator by the common denominator. Common denominator is 3. So we multiply by 3 denominator and we must multiply the numerator as well. Then the fraction will must change. So we multiply this fraction by 3 over 3. 3 over 3 is 1, so the fraction is the same. So we have 3 in the numerator and square root of 14 in the denominator. So MyMATLAB always asks you to rationalize denominator. It means that if you have a square root in the denominator, it's not good. We must read off it. So you multiply by another square root of 14, both numerator and denominator. So when you multiply numerator and denominator by the same number, it is the same as you multiply by 1. So square root of 14 over square root of 14 is 1. So you didn't change to your expression, original expression. Then in the numerator, we have 3 times square root of 14. In the denominator, we have square root of 14 times square root of 14, square root of 14 squared, or 14. So this is the answer. You see, the most difficult part of it is rationalizing the denominator, not the applying trigonometric identities. So the next problem, theta is negative 220 degrees. Find sine of theta, cosine of theta, and tangent of theta. So let us locate this angle on our Cartesian coordinate system. Theta is in the standard position, so the initial side is along the positive x-axis. Theta is negative. It means we rotate in a negative direction, so in a clockwise direction. In a clockwise direction, the first quadrantal angle will be negative 90. You know, every quadrant is 90 degrees. So 90, another 90 will be negative 180. Another 90 will be negative 270. So our angle is negative 220. So it must be between 180 and 270. 220 will be somewhere here, somewhere in the second quadrant, negative 220 degrees. Now we can tell all the signs. Sine of theta in the quadrant 2. Sine of theta is connected with y coordinate. Y is positive above x-axis, so sine is positive. cosine of theta, you remember that cosine is x over r. R is always positive, so the sign of cosine is determined by the sign of x. X is negative to the left of the origin. X is negative means that cosine of theta is also negative. And tangent theta, tangent is y over x, y over x. In the second quadrant, y is positive, we are above the x-axis. X is negative, so positive divided by negative, we'll have negative tangent. So you can also use another rule. Maybe you know this, all students take calculus. So better to write it in the Cartesian system so the positive direction is like this. We start from the first quadrant. All students take calculus. So in the first quadrant, all trigonometric functions are positive. All are positive. In the second, only the sign is positive. So since tangent and cosine are negative. In the third quadrant, only tangent is positive, since tangent is y over x. Both y and x are negatives, and negative over negative, positive. Tangent are positive. And so sine is positive. And here cosine is positive, since x coordinate is positive in the fourth quadrant and y coordinate is negative, so sine and tangent will be negative. For this rule, we only consider three functions: sine, cosine, and tangent theta. So the reciprocals like cosecant, secant, and cotangent have always the same sign. The sine and cosecant have the same sign, cosine and secant have the same sign, tangent and cotangent have the same sign, either both positive or both negative. And the next problem, cosine of theta equals square root of 7 over 3. We want to find sine of theta and tangent theta. So let us locate this angle. So, and we must know the quadrant. Without quadrant, we cannot tell the sign of sine and tangent. So let it be quadrant 4. Quadrant 4. So we can represent angle theta by the point on the terminal side of the angle theta. So we know that definition of cosine theta is x over r. From the other hand, cosine is equal to square root of 7 over 3. Let us take x equals square root of 7 and r equal 3. So if we would have a negative cosine, we will take x equal negative x, because r is always positive. In this situation, we have positive x, so no question. So that both must be positive, because r is always positive. So let us sketch this angle. X equals square root of 3. r square root of 7, sorry. R is 3. So this is 3. To determine other trigonometric function, we need to know y. For this right triangle, let us do this right triangle here. We know that one side, one leg is square root of 7 and hypotenuse is 3. For the right triangle, we can write Pythagorean theorem, hypotenuse squared, 3 squared, equals first leg squared, square root of 7 squared, plus second leg squared. So second leg is the y-coordinate of this point, let us call this y, so plus y squared, and we must solve this equation for y. Let us square these two numbers, so 3 squared will be 9 equals square root of 7 squared will be 7 equals y squared. Subtract 7 from the left and from the right. We get 2 equals square root of y. We solve this equation by square root property. We not just take square root of this expression. Be careful. Y is equal positive or negative square root of 2. Don't forget this positive or negative, because both square root of 2 and negative square root of 2 are solutions of this equation. So, but we can decide which sign is better. Since we are in quadrant 4, y must be negative. So from these two signs, we choose negative. So y is negative square root of 2. So what do we have? We have x equals square root of 7, y equals negative square root of 2, and r equals 3. Now we can write all 6 trigonometric functions. We are interested in sine and tangent here. Sine of theta equals y over r, so negative square root of 2 over 3. And tangent theta equals y over x. Y is negative square root of 2 divided by square root of 7. And we want to rationalize this, so we multiply by the square root of denominator, numerator and denominator of our fraction. So this is square root of 7 over 7 is 1, so we don't change the value of tangent. Okay, in the denominator we have square root of 7. We got 7 in the denominator. In the numerator, we have square root of 2 times square root of 7. The product of two square roots can be written under one square root sign, so negative square root of 14. This is the tangent, and this is the sine. You see both sine and tangent are negative in the quadrant 4.